An 18-centimeter willow hit the water at dawn. The sound carried across the gravel flat, then silence, and the stream began to slow. Not a machine, not a concrete pour. One beaver, dragging timber across the channel, mouth in the Dyfi Valley, mid-Wales. October 2023. The work had already started. I'm Dr. Raymond Finch. I spent 40 years watching streams die, slowly, quietly, without ceremony. I have stood on a lot of dead banks. I had never seen a river answer this fast. 6 animals total, 2 breeding pairs and 2 juveniles, released into a channel so degraded the streambed ran completely dry every August. A dead stream in every practical sense. The water table had dropped so far that August flows were zero. The gravel sat bleached and exposed under open sky. Nothing held moisture in that valley floor anymore. Within 72 hours of release, the first tree was down and across the channel. That is not a metaphor for gradual change, that is 72 hours. Dr. Emma Sherwood, hydrologist and lead monitor for the Wales beaver trial, was on that bank with a flow gauge expecting baseline readings. She got something her model said was 3 weeks away. Her model projected a minimum 3-week lag before any measurable velocity reduction. She documented the reduction before her first site assessment was finished. The numbers did not agree with each other. Beavers have been engineering water systems for 6 million years. Every dam they build is a solved problem. Sediment trapped, water table lifted, channel stabilized. The animal does not consult a model. What Sherwood measured that morning in the Dyfi Valley was a downstream velocity drop from a single felled willow. One tree, 18 centimeters across, placed by an animal that has no permit. The stream slowed. The data said it should not have. And across the next 18 months, what grew out of that contradiction would change how the valley held water, permanently. Drive the BB 4404 into the Dyfi catchment on a clear morning, and you will see green hillsides, clean air, the kind of countryside that sells itself on postcards. Nothing looks wrong. That is the problem. Below that surface, the food web had already lost its lowest floor. The streambed held fewer than 4 macroinvertebrate species per sample site. Healthy Welsh rivers typically carry between 20 and 30. Everything above that missing foundation was eating borrowed time. 4 species where 20 to 30 should live. That gap is not a setback. It is a collapsed foundation with nothing left to rebuild from. Dr. Sherwood had walked every reach of this system by 2022. She told me the most disturbing number she ever recorded was not a pollutant concentration. It was silence. 0 calling dippers along a 2-kilometer stretch that should have held at least 6 breeding pairs. A river makes a particular sound when it is alive. This one had stopped making it. The geographic record makes the scale visible. At the core Dyfi reserve boundary, riparian willow coverage had fallen below 8% of its pre-drainage extent. And otter spraints had been absent for 11 consecutive survey years. Near Llanbryn Mare, summer temperatures peaked above 19 degrees Celsius, the threshold at which juvenile brown trout cease feeding, and the trout population had declined by roughly 70% over 2 decades. Along the Avon Twyman, phosphate loading sat at more than 3 times the threshold for good ecological status. In the Plyn-Lyman uplands, drainage cuts from the 1960s had dropped the water table by an estimated 40 centimeters, turning a slow-release sponge into an erosion-prone slope. That 40-centimeter drop in the water table sounds modest, but across hundreds of hectares of peat, it converted a system that once absorbed rainfall gradually into one that shed it fast, violently, and with force enough to scour the beds downstream. The riverbed along the Twyman was blanketed in fine gray silt, the kind that fills the gravel pockets where salmon lay their eggs and seals them shut. No oxygen reaches the embryo. The red becomes a grave. Here is what the surveys confirmed by the time the release date was set. The Dyfi catchment was not in decline. It had already declined. The 6 animals arriving in October 2023 were not entering a stress system. They were entering a quiet one. And somehow, within 18 months, the phosphate readings that had held above legal thresholds for over a decade began to shift. No one had engineered that. No contractor had been paid. No permit had been filed for the sediment retention that drove it. The mechanism, exactly how 6 animals reversed a nutrient load that regulatory programs had failed to move, was not yet written in any published report. The phosphate numbers had shifted, and nobody had filed a permit for that. But here is the part Dr. Emma Sherwood described to me with the flatness of someone reading a null result for the 10th consecutive time. Years before 6 beavers arrived, this valley had already been a project. Buffer strip fencing had gone in across participating farms. Willow spiling crews had worked the banks. Sediment traps had been bolted into the riverbed by contractors with licenses and invoices and scheduled maintenance windows. Phosphate reduction grant schemes had run for a full decade, drawing from Welsh Government agri-environment funds. Multiple Welsh Government reports placed the combined public expenditure across those programs in the low millions of pounds. Surveyors measured modest bank stability improvements at 3 fenced sites. Phosphate readings dropped marginally at 1 monitored point. The macroinvertebrate index did not recover. The dippers did not return. The water table did not rise, not 1 centimeter. Dr. Sherwood submitted every monitoring cycle to Natural Resources Wales. She told me the pattern felt like pressing against a wall that absorbed the effort and gave nothing back. The institutional resistance to what came next was not invented. A formal agricultural objection was lodged in 2021, citing waterlogged pasture and blocked drainage infrastructure. Natural resources. Wales then required 18 months of ecological impact assessment before a license could be granted. That is not obstruction. That is a system doing what systems do. The objection was not unreasonable. During the beavers' second winter, 1 downstream field did flood. The farmer involved entered a compensation negotiation that ran for several weeks. Nature is not tidy. It never promised to be, and yet, within 18 months of release, the local water table had risen by a documented 35 centimeters across approximately 2.5 hectares of valley floor. No engineered intervention across the preceding decade had moved that number by a measurable margin. 6 animals, no salary, no machinery. This is the part that made me stop and reread the field notes. Dr. Sherwood's model had projected a minimum 3-week lag before any measurable hydrological response post-release. The first velocity reduction, caused by a single 18-centimeter willow felled by 1 beaver, was recorded within 72 hours, a number that should not have been possible that fast. The macroinvertebrate surveys from the following spring showed early recolonization at 2 of the 4 monitored points closest to the dam structures. No contractor had seeded those invertebrates. They arrived because the substrate conditions finally allowed it. The stream had begun, very quietly, to make sound again. What 6 animals built in 18 months was not elegant. It was functional. It was wet and tangled, and exactly what the valley had been missing for decades. The question now was whether the institutions that had spent years and millions trying to replicate this outcome were prepared to learn from the thing that actually worked. The dominant male weighs roughly 25 kilograms. He works at the waterside alder for under 2 hours, stripping branches, dragging the trunk, and then the channel has a dam where it had nothing the morning before. Water backs up behind the trunk. Velocity drops. It is not a plan, scheme. It is one animal doing what the species has done for millions of years, and the stream has no choice but to respond. Within the first 4 weeks, Dr. Sherwood's monitoring team recorded 3 distinct pool structures forming upstream of the primary dam, where every previous survey had found only uniform shallow riffle, edge to edge, with nowhere for anything to slow down and settle. Silt that had been flushing out for years now settled. By the end of the first season, 4 centimeters of fine organic sediment had accumulated across the pool floor. The kind of substrate aquatic invertebrate larvae colonize within days of it stabilizing. Stonefly nymphs had been absent from every pre-release kick sample taken at this site. They need clean, slow, oxygenated water, exactly what the Reach had not been able to offer. At 6 weeks post-release, Dr. Sherwood's team pulled their sample net and counted, then counted again. Pre-release, 0 stonefly nymphs recorded across all monitored kick samples. 6 weeks after release, present in numbers, the team felt the need to verify with a second count. That is not a gradual recovery, that is a threshold crossed. By month 4, the pool margins were holding standing water between rain events for the first recorded time in monitoring history at that site. Marsh marigold appeared along the wet margin the following spring. Its seed bank had been dormant in that soil, waiting. By month 7, a breeding pair of dippers had established a territory centered on the primary pool. 2 birds in a reach that had recorded 0 for 11 consecutive years. Their return was not miraculous. It was hydraulic. The pool gave them the invertebrate density they required, and they moved in. By month 12, the pool head was running 2.1 degrees Celsius cooler than open riffle sections downstream. Increased water volume and bankside shade from new willow regrowth were acting as a thermal buffer. The precise thermal condition juvenile brown trout require to resume feeding. The trout returned before the scientists had finished writing the paper, explaining why they would. The dam was not the restoration. It was the keystone that unlocked a sequence no management plan had ever achieved in the correct order, at this site, in this catchment, without machinery. What no one had yet fully explained was how a single felled trunk, placed by one animal in a single night, had triggered thermal change detectable at 12 months. The mechanism from dam to temperature differential to trout presence had been documented. The speed of it had not been explained. That gap in the literature was still open when the next season began. The gap in the literature was still open, and the beavers were already somewhere the literature had never thought to look. By the 14th month, a secondary dam was standing on a reach the 2021 Ecological Impact Assessment had classified as unsuitable. Unsuitable because of gradient. Unsuitable because of substrate type. The assessment was not careless. It was written by people using every tool available. The beavers had no tools. They had instinct, and that turned out to be enough. The original population model projected a stable group of 6 to 8 animals across a 1.5-kilometer management zone for the first 3 seasons. By month 14, there were 9 individuals. The kit cohort had survived at a rate the team had conservatively discounted. And then they moved, 340 meters past the downstream boundary of the agreed management area, into the reach that should not have held them, where they began building. Dr. Emma Sherwood, hydrologist and lead monitor for the Wales beaver trial, walked that secondary site in the spring of the second year. She told me she stood there for a long time. She was looking at a pool the assessment said should not exist. The unsuitable reach was now producing the same macroinvertebrate response as the primary site, 6 weeks behind in the sequence, but tracking it precisely. The gradient had not changed. The substrate had not changed. The engineer had changed. A public footpath along the south bank flooded when the secondary dam raised the table across a low-lying field margin. The path closed. A local walking group filed a formal complaint. A regional newspaper ran a headline using the word invasion. The dam did not read the headline. Across the wider enclosure, 2 mature crack willows were felled overnight. No warning, no negotiation. One of them was a tree the farm had named informally. The kind of tree a family had sat under for decades. It was gone by morning. The beavers did not build what the management plan permitted. They built what the valley needed. And the valley responded to exactly that. Not to the plan, not to the model, not to the assessment, to the build. Every model had been built around 6 animals in a defined zone. Now there were 9 in 2 zones, on a reach declared unworkable. And both zones were producing ecological sequences no intervention had ever replicated here. What the next season would bring, no projection had yet been written to contain. What the Dyfi gave back in 18 months was not a gesture. It was a reckoning. Soil holding water it had not held in living memory, channels braiding where a single carved cut had run for decades. Dr. Emma Sherwood had stood on that bank in October 2023, with a flow gauge she expected to read baseline. What she recorded instead, a measurable velocity drop within 72 hours of release, was caused by a single 18-centimeter willow placed by one animal. She told me she looked at that number 3 times. Her own projection had called for a minimum 3-week lag before any detectable change. The instrument did not agree. By the close of the trial's second season, the restored reach was retaining sediment at a documented rate of 1.4 tons per hectare per year, a figure the site had not produced under any prior intervention program. The macroinvertebrate count at the primary site had climbed to 34 documented taxa by the end of the second survey period. That number is not a symbol. It is a food web rebuilding from the substrate up, one species at a time. Brown trout were recorded holding in the slower water behind the primary dam structure. 11 individuals counted in a single electro-fishing pass, where the survey team had recorded 0 in the baseline run 2 years prior. 0. Then 11. The system did not wait for a second opinion. Remove the pressure, return the missing part. The physics resumes. That is not restoration as policy. That is hydrology completing a sentence it was not allowed to finish. Tell me in the comments where you are watching from, and name one species you have personally seen disappear from that place in your lifetime. A bird that stopped calling, a fish that stopped running, an insect that stopped lighting up the summer evenings. And yes or no in the comments. Have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent because the evidence says otherwise. In the Cairngorms of Scotland, Eurasian lynx are being formally assessed for reintroduction across a range-losing riverbank at a measurable rate, tons of soil per kilometer per year, washing into the sea while red deer graze the roots holding it in place. NatureScot rejected a formal lynx reintroduction proposal in 2023, citing livestock predation risk, a position that holds even as the banks keep collapsing. The question the next film answers: how long can a landscape survive the certainty it is waiting for? I'm Dr. Raymond Finch. I'll see you in the field.